Yeah, that's for you. Okay, it's 4 o'clock, and we will get this seminar started. So I'm Daryl Thalen. I'm the chair of mechanical engineering. For those of you that don't know me, we're super excited to have this Distinguished Alumni Speaker Series this year. It coincides with the 150th anniversary of the department. And in thinking about how to celebrate this, one of the things we really wanted to do is just bring back some alumni who went through this educational experience that you're going through right now years ago, and then went on and did pretty remarkable things, and that have remained connected with us. And we were really fortunate because we invited a number of people, and they all said yes, which just goes to speak to, I guess, maybe Jim will share a little bit, but the importance of the experience they had here in their future careers. So we have a really exceptional lineup. We had the dean of the College of Engineering kick it off in the last, 2 weeks ago in this seminar, and a number of speakers to come. So today we're really fortunate to have Jim Berbee, and I found this and I thought it was fitting because I guess the picture on the left, is that undergrad or grad?
That might have been high school.
Publicly available, okay, so I didn't, you can do a search for Jim Berbee, and it's one of the first photos that comes up as the juxtaposed pictures. But anyway, so Jim did his undergrad degree in mechanical engineering here. He stayed on and worked in the ERC as a graduate student, got his master's degree, and then ended up getting his MBA. So when he left here, he first worked for IBM. Then he started his own company called Berbee Information Networks Corporation, and started that in Fitchburg. And then a company that really took off, got some big name clients, did extremely well, and then he sold it to CDW, I guess. And for reasons that maybe he'll explain to us, at that point he decided to go to medical school. So he ended up at Stanford and did his medical degree, and then came back here for his residency in emergency medicine. And then I think and maybe I'll talk about this, is that's where he combined kind of that engineering background in medicine, and now he's been an entrepreneur and designing medical devices and very involved in that thing. And if that's not impressive enough, he's also done multiple Ironman triathlons and is a pilot, so somehow he finds all that time. And I way before knowing Jim, I knew about this, which was the Berbee Derby, which is a remarkable race. I'm a runner myself, and he gets thousands of people to get up early on Thanksgiving Day morning to come out and run either 5K or 10K. I assume that's you up there in the front somewhere, Jim, leading the pack. But anyways, that race is still going on, so you can participate yourself someday. So one fortunate thing is Jim in graduate school actually went to graduate school with a couple of our faculty, one of which is Jal Gandhi's here, and Jal has, I guess, an artifact from the day that he's gonna tell us about. Oh, yeah.
All right. Thanks, Daryl. So a few things maybe to add that Daryl didn't share. Let's see if I can get this. Okay. That's it. We'll get there yet. So Jim is actually a lifelong Madison resident. So I looked up his thesis on the library website this morning, and so 1987 thesis: aspect ratio and Reynolds number effects on the flow behind a rearward facing step. So that was under J.G. Berbee. In addition, there's another J.G. Berbee thesis in the archives of the University of Wisconsin from 1954, the prevention of the damping off diseases of coniferous seedlings. So Jim will be happy to answer questions on both topics as we get going. So Jim did, get his bachelor's in mechanical engineering, stayed on, and did his master's, and then got an MBA, like Daryl mentioned, but what he didn't mention was that while Jim was doing his MBA, he was actually still working in the Engine Research Center and for the department. And he maybe is the only person that put himself through business school by teaching thermodynamics to undergraduates. And during that time, I got to know him as a student in the ERC myself at the time, and as graduate students do in the middle of the afternoon, we maybe had a little bit of steam to blow off, and so Jim and I would go over to Union South in its previous incarnation and play ping pong in the middle of the afternoon. And not to pat myself on the back too much, but I used to kick his ass all the time. And then finally I was getting ready to leave. We went to play one final match of ping pong. And I won't say that I took a dive for the team, but let's just say in the final match, I came out on the short end. And Jim has basically, parlayed that into the successful career he's had since then. So oops, wrong one. Let's try this one. At the time, we were prescient, and it's hard to see, but this is a ping pong ball here, right? That says, to the master, Jal Gandhi, that's me, right? Then the scores, which are a little unfortunate for me, let's just say, came back to win the second match, but lost the third one, and the date of March 29th, 1989, and signed. And so finding this was a bit of a ordeal, and so at this point, I've held it for 36 years, and I'm going to give it to Jim for him to hold for the next 36 years. And so with no further ado, we will let Jim actually talk about something maybe a little more interesting. So.
We got to do it officially.
Do the official.
There we go. All right, great, thanks. Thank you, Chair Thelen, and Professor Gandhi. Thank you very much for that really kind introduction. That all of you sitting here at your stage in your career, you won't believe how fast the years go. We were just sitting in Professor Gandhi's office together, and literally it was just yesterday that we were young graduate students, and we'd go over to Union South when we should have been working and playing ping pong and eating popcorn and having ice cream, and it was just terrific. So I'm delighted to be with you today, and I thank both of you for the very kind introduction. And one of the things I say to everybody is, if you think about, I think the very best education you can have, mechanical engineering is right up at the top, and I would absolutely credit mechanical engineering for sort of everything that followed in my life. And I'll tell you some stories related to that. But there's something about mechanical engineering and engineering in general, it's maybe unfair to be specific about mechanical, that teaches you to think critically. It teaches you to think about more than just the immediate problem and the immediate effect of the problem. That really serves you well. So I congratulate all of you for being in engineering. I think it's going to serve you well. In particular, I congratulate you on being in mechanical engineering. And of course, I had to go to ChatGPT because I had to come up with a mechanical engineering joke. And so the mechanical engineering joke that ChatGPT told me is, why did the piston break up with the cylinder? He couldn't take the pressure. I know. I thought it was pretty weak too, but that was the best of all the ones ChatGPT gave me. So anyway, so I thought what I'd like to do, because I'd like to tell you some stories today. I'd like to do it in a parable that maybe some of you have heard about this parable before. And the title of this talk is it a good thing or a bad thing? And the parable goes like this. So there's a Japanese farmer, and the Japanese farmer is working on some very beautiful fields. And he's got a very content life. He's able to feed his family without any trouble at all, and he has everything that he needs. And the Japanese farmer is part of a feudal system, and there's a shogun. And the shogun decides that he's going to go to war with the province next door. And so he goes to war, and the question is that a good thing or a bad thing that the shogun's going to war? Well, it turns out that because the shogun's going to go to war, he decided that he was going to give the farmer a horse because he wanted the farmer to be able to be more productive in terms of growing crops. And the question is that a good thing or a bad thing that the farmer now has the horse? So the farmer's son was on the horse, cultivating the fields, and the farmer's son fell off the horse and broke his leg. And the question is, okay, now is that a good thing or a bad thing that the farmer's son just broke his leg, right? And so, because the farmer's son broke his leg, he was not able to go to war because he was injured. Okay, is that a good thing or a bad thing that he wasn't able to go to war because he was injured? Well, it turns out that the shogun won this particular battle and was able to get additional farmland. And because he got that farmland, but because the son didn't participate, the son wasn't given any more agricultural land. Is that a good thing or a bad thing? So you can kind of tell that the parable just goes on and on like that. But the bottom line of all of it is it a good thing or a bad thing when something happens? And what I would say to you is that you don't really know when something happens if it's a good thing or a bad thing. And even with a lot of time, you don't know if something's a good thing or a bad thing. It's not just a matter of perspective, it's a matter of all the additional effects that are going on. And I think about it in terms of engineering. If we make an engineering decision, like say we're going to pick a particular material for a part that we're making. So that's the primary decision that we're making. And then what's the secondary decision? Well, was that material robust enough? Did it hold up in the environment that the application's designed for? And if it did that, then then the third consideration may be, was it cost effective, right? Was I able to produce it in a cost effective manner? So one of the neat things is I think engineers are really trained to think about not just primary decisions, but also secondary, tertiary, and quaternary effects, right? So it's not just the initial decision, but it's all the things that happen along the way. So I think there's a real symmetry between, is it a good thing or a bad thing, and what are all the consequences of any one decision that you make in your life? So I'd start out by telling you, and luckily Professor Gandhi and the chair didn't know about this, but I was a freshman in mechanical engineering. I was a second semester freshman, and I was working at the Region Apartments, which I think is still next door, one of their apartments. And I was the resident manager, and I was very, very busy doing that job and being an engineer. And I was so dedicated to the work at the Region Apartments that it's fair to say that my engineering work really suffered, right? So is that a good thing or a bad thing? Well, it turns out that semester I kept dropping classes until all I had left was thermodynamics, a three-credit class, and dynamics, which was a 4-credit class. And I don't know if those are the same classes you guys have today or not. But anyway, those were the only classes I had left. And when the semester finished, I got an F in thermodynamics, and I got a D in dynamics. How I got a D, I don't know, because I probably didn't deserve it. And my grade point, it's still burned in my retina. My grade point was .571 that semester, right? Is that a good thing or a bad thing? So I was literally waiting for a letter from Dean John Bollinger, that's his car, the pink car out in the lobby. So I was waiting for a letter from Dean Bollinger inviting me to take some time off from engineering. And it didn't happen. It didn't happen. But what did happen is one day I was walking by the engineering campus, actually outside of what is now the engineering building, and I saw construction workers putting in piping systems for a steam system or something for the campus. And I saw these people out there working, and I saw how hard they were working and how grueling that work was. And I thought to myself, and I had a tremendous respect for that kind of work, right? I was brought up to respect any kind of work and honorable work. But I looked at it and I thought to myself, that is just not the kind of work I want to do for the rest of my life, right? And so it was that in context with the .571 was very, very motivating. And as a result of that experience, I never got, I got one B. After that, I got a bachelor's in mechanical engineering, a master's in mechanical engineering, MBA in finance and investment banking, a medical degree. And all those degrees, the worst grade I ever got after that .571 was a B, and it was in marketing. And to this day, I hate marketing. I just despise marketing. I mean, I never understood it, and I still despise it. But it was really it was really motivating. So this is a story of a good thing or a bad thing. So I got a .571. You know, is that a good thing or a bad thing, right? It was incredibly motivating, right? Is that a good thing or a bad thing? It launched me on a career of, you know, of exceptional focus on being able to learn and absorb information. Is that a good thing or a bad thing, right? It gave me sort of singular focus on wanting to accomplish goals and objectives. Is that a good thing or a bad thing? That singular focus on goals and objectives was very damaging to personal relationships. Is that a good thing or a bad thing, right? So it's just, there's always these secondary and tertiary effects to everything, right? And you sort of, again, and that chapter is still not written and won't be. But that's one of the things you have to ask yourself, and one of the things you learn along the way is what are you capable of? And being challenged with that really bad performance, that really bad outcome, was really challenging for me in terms of what are you capable of and what are you capable of learning. And then you learn that you're really capable of learning and processing a lot of information and going through a lot of details. So, what are you not good at? This is a picture of a data center. So when after my epic win against Professor Gandhi, I went to work for IBM for a few years. And then after I worked for IBM for a few years, I started my own company called Berbee Information Networks. And what we did is, Berbee Information Networks was Jim going out to companies and essentially helping them get their computer networks to work. So none of you remember this. This was back in the day when the internet didn't really exist, right? There's the IBM mainframe, and everybody was connected to the mainframe. And it was just the time when the internet was coming out and when people were trying to connect things together. And so there's tremendous demand for somebody that knew how to connect things together and get things in their network. And now, you know, we're also used to TCP/IP and internet protocols. But back in the day, it was NetBIOS, it was system network architecture, it was, God forbid, Apple Talk, right? All those kinds of things that were used. And so the ability to integrate computer systems was at high demand. So I still remember when I decided to start this company, I was going to leave IBM, and I went in and talked to Professor Ragland, who was one of our senior professors at the time. I said, Professor Ragland, right down in ERB, I still remember where his office was. There's a good chance that after I start this business that I'm going to fail miserably. And if I do, can I come back and teach thermodynamics again? That was part of the story I didn't tell you. I actually became a lecturer for thermodynamics and taught like thermodynamics and heat transfer and all those kinds of things. So if any of you get an F, there is redemption. You can get beyond it. So anyway, I chatted with him about that, and he said, yeah, you know, sure, but I kind of thought he probably thought that wasn't going to be necessary. So it started the company, and initially it was me going out to companies like Land's End or Harley-Davidson and helping them with their networks. What bothered me, so is that a good thing or a bad thing? Well, it was a good thing because you made some money, but I recognized that it wasn't scalable. In other words, it was hard to get to be a big company with just one person going out and fixing stuff, right? So along came this thing called the internet, right? And I still remember my wife was a dean at the College of Engineering. I actually met my wife in the basement of the Engineering Research Building. And she invited me over one day to her office in Kurt F. Wendt, which used to be the library, and said, hey, I want to show you this thing called the web. And I remember sitting down at her desk, and I was like amazed. It was just incredible. And at that time, all the web was like able to show an image was about all it could do. It didn't have links and searches and all that kind of stuff. But I thought that's really cool. So I decided that's got to be the future of networking is being able to connect to the internet. And so I bought a fractional T1 connection to the internet. I installed a bunch of modems, and I started becoming an internet service provider, right? So that was back in the day when you could do that kind of thing. So, and I still remember talking to my big customers, like Land's End, for example, and they'd say, there is not a chance in heck that we're ever going to have a connection to the internet. That's the Wild West. This company is never going to connect to the internet. That was the mindset back. I know you can't even believe it now, right? But that was the mindset back then. So, we installed these systems, we grew the data center, we expanded as the world expanded and stuff. And then we decided that we were going to build a major data center, right? Not by the scale of today's major data centers, but we were going to build a data center in Fitchburg that was about a $6 million data center, backup generation, multiple internet connections, raised floor, heavily air conditioned, rack-mounted systems just like this. We decided that was what we're going to do. And the nice thing about data centers is the minute you get a server in the data center, it's very, very sticky. A customer, once you get a customer, it's very hard for them to leave, right? And once you get a customer, the customer grows. And so more servers come in, more backup comes in, more power is required. So it's just a great business. It's a hard business to get started because it's high fixed cost, $6 million. But then once you get all your customers, you're just printing money. You just sit back and cash the checks, right? So that was my vision for what we're going to do. So we went out and we raised, I think it was $6 million or something like that to build the data center. And then the world fell apart. This was back in 2008. Our professional business was hurting. We had these external investors now that expected, good solid performance. We were losing, $100,000, $200,000 a month, which at that time was a huge amount of money. And we had come to Jesus meetings with our investors. They literally said, you got to come and talk to us about this and tell us what you're going to do about it. And that was when I realized that I am really good at starting things and really good at ideas and really good like excitement, and I am really, really bad at managing things, right? So luckily I had one of my classmates and another UW alum, Paul Shane, came on board, became the CEO. I became sort of the technical head. We worked our way out of that particular problem, and then eventually was able to sell the company. So again, what's the good in the, is it a good thing or a bad thing? Well, professional services, is that good or bad? Well, it's good because it's easy to start. It's bad because it doesn't scale, right? You go out and you get investors. Is that to build a data center? Is that a good thing or a bad thing? Well, it's a good thing because now you have capital to build something that's going to have sustainable recurring revenue. It's a bad thing because now you got people that expect a return on their money, right? Okay. You run the business almost into the ground. You have to lay off people. Is that a good thing or a bad thing? Well, it seems like a pretty bad thing, but it's, again, another wake-up call, right? It adds incredible discipline to your company to never make that mistake again, right? So then you work your way out of it, and then you eventually sell your company for $175 million back in 2006 or whatever. Is that a good thing or a bad thing? Now, I know what you're all thinking. How's he going to make a bad thing out of this? Okay. No, there's really nothing bad about that, except there's something to be said about constantly striving. The human condition is not meant to be placid. It's not meant to sit back and do nothing. And so the danger when you have something like that happen is then what do you do, right? It sounds like all your problems are over when that happens. And yeah, okay, life has gotten more comfortable certainly, but all your problems really aren't over. And so the question remains: is it kind of a good thing or a bad thing? So that's the question: is what do you do when your dreams come true? And one of the interesting things too, I'd tell you is, my goal was never to be rich. I talked to a lot of people where it's like, yeah, I want to be, whatever. I want to be rich. And it's never that I didn't want to be rich. It's never that I didn't want to be comfortable. It's never that I didn't like nice cars or whatever the issue is. But it was never really my goal. My goal with everything I did with the computer stuff, I loved it. I just loved the problem of solving a customer's problem. If there was a problem where something wasn't connecting, something wasn't talking to each other, I had endless amounts of energy to deal with it. I could spend, it never tired me out, trying to solve the problem and figure out what was going on. Now, human problems is a different matter. If I had unhappy employees or people that were mad at me, that wore me out. I had that I just didn't deal with. But technical problems I could really do well with. So sold the company, and then I was at the time as mentioned before, I was training for an Ironman, and I was out on a training ride with a bunch of my friends, and I crashed my bike, and I deliberately said crashed my bike, but it's more accurate to say that I fell off my bike because it was quite a low-speed accident, and I fell off my bike and I broke my collarbone, the clavicle you can see there. That's not actually mine, but it represents the issue. And I went to the emergency department, and I was sitting there in the emergency department. It's a little bit uncomfortable. And the doctor came in, and he's talking about, your clavicle is broken, blah, 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 blah. Surgery's not necessary. It'll heal by itself. And then in the next cubicle, not cubicle area, curtained off area, because it wasn't doors, it was like curtains. There was somebody that was clearly kind of a drug seeker. And I was watching the emergency doctor, where with me, it's like, how many oxycodone would you like? He's really, right? And then for the person next door that was kind of clearly a drug seeker, it was like, he's really being, no, I'm sorry, I can't give you anything, blah, 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 blah. And it made me start to think, I wonder if this is something I could do. And this was sort of towards the end of my company, when my company was doing really well, and it was clear it was going to do just fine. And I was thinking about what I was going to do next. And so that kind of opened up my mind of, I wonder if I could become a doctor, an emergency doctor. It seems like it fits my personality pretty well. I don't have to have relationships with anybody. They come in and they see me. It's like engineering, right? I just, I see them, I fix them up. I never see them again. And then when I didn't know emergency medicine very well, I was sort of like, well, what's the downside? You know, it's emergency medicine. If they die, you know, it was an emergency, so it's clearly not your fault. So there's nothing, right? So I sort of, this side checks all the boxes, right? And obviously, I learned later that that's not exactly what emergency medicine is, right? But so that started me on that. So again, it was sort of the same. Is it a good thing or a bad thing, right? You know, so you crash your bike and you break your collarbone. You know, is it a good thing or a bad thing, right? Then you're introduced to this emergency doc that, you know, kind of has an interesting role. Is that a good thing or a bad thing? And then you decide, I could maybe that's something I could do. And I still remember, because by this time I was fairly well known in Madison, because my company was one of the first darlings of the internet age, you know, at a Madison scale, not at a Facebook scale or anything like that. And so I thought to myself, well, you know, I've got degrees in engineering. I've been a successful business person. I'm just going to go talk to the dean of admissions, and she'll probably just invite me to, you know, sign up for the next class, right? So I go see the dean of admissions, and I sit down in her office. You know, I'm kind of dressed like this, right? I got dressed up a little bit and stuff. And, I sit down. I said, yeah, I'd like to go to medical school. And she looks at me. She takes one look at me and says, well, that's great, Jim. You need organic chemistry. You need physiology. It probably wouldn't hurt you to have some languages. Oh, by the way, you're going to have to take the MCAT. So, you know, two years when you're done with all that stuff, come back and talk to us. And I remember I was just like so bitterly disappointed. It's like, don't you know who I am? I was sure I was going to get the golden ticket to medical school, right? And I think back about that, and I was so disappointed. And then I realized how important that was. Because if you weren't willing to do those few little things just to even get to the point where you could apply for medical school, you were never going to make it through medical school, right? And so you think about the people that did you a favor, but that just killed me. You know, it's like, oh yeah, sure, Jim. You know, here's all the things you have to do, and there's still a good chance we won't admit you, right? Because it's so damn competitive. There's people like you all over the place now that are. You know, I was 40 years old when I was applying to medical school. There's people like you. I remember when my first week in medical school, we had histology labs. And I had a rough idea that there was like red blood cells and white blood cells. I kind of got that. Who knew that there were different kinds of white blood cells, right? And all my fellow classmates, that's all they knew. You know, they knew neutrophils, they knew leukocytes. And I'm like, I couldn't identify one of those if it hit me in the face, right? And so anyway, it was good to have that. So again, you know, is it a good thing or a bad thing? You crash your bike, right? Then somebody tells you, no, we're not going to just admit you to medical school. You got to do the hard work that everybody does, right? And then what a gift that was, because you never would have gotten through it, you know, if you hadn't done that hard work and been committed to it in the first place. And then I would tell you kind of an interesting story too. Emergency medicine was really an interesting experience. I practiced for probably 5 or 6 years. I finished my training. As was mentioned, I went to Stanford for medical school, and then I came back to Wisconsin. I did my emergency medicine at the UW hospitals right next door to us. And it was great because as part of the program, you got to fly in med flight. So I got to be a med flight physician too, which was like the best job in the world. Flying out in the helicopter, going to accident scenes. I mean, not good for the people at the accident scene, but a lot of emergency medicine wasn't emergencies. A lot of it was like sore throats in the middle of the night, that kind of stuff. But if you're going out in the helicopter, it was probably pretty real, whatever it was going to be. It was always kind of fun too, because I have a helicopter, I have a rotor license too. I always kind of wanted to fly the helicopter, but they never let me do that, unfortunately. So emergency medicine was really an interesting experience. And it's one of the things about, again, coming back to engineering training, is that thinking about does everything fit and does everything match the pattern that I expect it to match is really helpful. And I'll tell you 2 stories. One where I screwed up and one where I didn't. So at the time I was working at an emergency department up in Rice Lake, Wisconsin, which is a Marshfield Clinic emergency department. Small little emergency department, rural. We might see 15 patients a night or something like that. And so this young man comes in. He's probably about 16 years old or so, and he came in with abdominal pain. And he was there with his mother, which makes sense for a 16-year-old. So I go and talk to him. What's going on? I've got abdominal pain. When did it start? It started a few hours ago. And so I examined him, pressed on the belly, and I was like, well, it's the things you worry about. Appendicitis, right? Is kind of what comes to your mind. So I got the lab work, sent him for a CT scan to see if there was any evidence of appendicitis. And he came back, no appendicitis, right? And the blood work was normal, no elevated white blood count or anything like that. And so I went back in to talk to him, and I was, there was something about it that was bothering me, because the kid was kind of uncomfortable, right? And I sort of ignored that more than I should have, for sure. And I ended up discharging him. And then maybe like the next shift when I came in, maybe it's the next weekend or whatever, one of the nurses or one of the doctors said, "Hey, Jim, remember that 16-year-old that you saw a week ago?" And whenever you hear that as a physician, it's never, "Oh, they called to just tell you what a wonderful job you did." That's never what happens, right? Whenever you hear, "Do you remember that patient?" it's never good. It's always something's gone wrong. And sure enough, in this particular case, the kid had testicular torsion. So one of his testicles had gotten torqued. And when that happens, the blood supply to the testicle gets cut off. And in this particular case, it was bad enough that the young man lost one of his testicles, right? So as you can imagine, that doesn't make you feel so good, especially when there was something about it that was just kind of nagging at you. And then you think to yourself, why on earth didn't you do a testicular exam on that young man, right? Why did that not cross your mind? And so you're mad at that, right? You're really upset about it. It was a bad outcome for the kid. It was something you missed that you shouldn't have missed. And then the question is it a good thing or a bad thing? And so sometime later, probably in that same year, this elderly couple came in. This gentleman and his wife came in, and the wife was saying, "Yeah, I've got shoulder pain. My back hurts a little bit. Sort of back up on the right side." I was like, "Well, tell me a little bit about that. Does it hurt more when you move your arm?" Yeah, it does kind of hurt more when I move my arm. And it's like, "Okay, are you short of breath at all? Are you nauseous at all?" "No, not short of breath, not nauseous at all. Never had any history of any heart problems or anything like that." But there was something about it that was just bothering me. And this night was a really busy night. This was one of those nights where, I had a stroke patient in one room, and I had a motor vehicle accident in another room, and I had this patient. And when you're in emergency medicine and you see a patient, when a patient first walks in the door, the only thing you think about with that patient is, what do I do with this patient? And there's two choices. You either admit them or you discharge them, right? And so right away, from the first time you see somebody, you're sorting out, what do I have to do to figure out which pathway this patient has to go through? And so that's going through my mind. But there's something about it that's just not quite right, about the way she looks and about the way she's describing her pain. You could try, it's musculoskeletal pain, right? It bothers her when she reaches up or whatever. But it bothered me a little bit. And so I got the EKG, obviously. I got the troponins, the cardiac enzymes, The troponins were fine. The first troponin was fine. The EKG did not show any sign of an ischemic event. There was no sign of a heart attack or anything like that. But something that still bothered me. And, the easy thing to do would have been just discharge, right? Discharge the patient. Now I don't have to think about it anymore. Now I can focus on the stroke. Now I can focus on the motor vehicle accident or whatever. But just something bothered me. So I went back in. So the other option you always have is to buy yourself time. So I went back in and I talked to the patient and the husband. I said, "Look, everything looks fine so far, but I'm just a little bit worried about this. If you don't mind, I'd like to have you stay for a couple hours, and I'd like to do a repeat lab work, and I'd like to do a repeat EKG just to make sure nothing's changed." Like, sure, that's no problem at all. So I came back a couple hours later, got the repeat lab work, and the repeat lab work showed the cardiac enzyme above what the first value was, but still in the normal range, if that makes sense. And the EKG was a little bit different, but still not pathognomonic for a heart attack. And so I looked at that again. I was like, I'm just a little bit worried about this. And so I kept them again, and I think like a half an hour later, did a repeat EKG, and the repeat EKG showed a clear heart attack. Now it was a fulminant, clear heart attack going on in the patient. And so I go back and say, where I worked in Rice Lake, we didn't have cardiology. We didn't have the ability to do any kind of interventions like that. So I called down in Eau Claire, where the nearest hospital that could do that kind of work was. Explained the situation, got a helicopter, helicopter down there, and then what was neat is you almost never hear, once that happens, you almost never hear what happens to the patient, right? But the next day I was working again. The husband actually came by and said, "Hey, I came by to thank you. My wife had like a 95% blockage. The cardiologist said she would have been dead, if you hadn't turned down there." And you can tell I still get a little choked up about it because it was actually Mother's Day too, so I thought that was kind of cool. So anyway, the kid that lost his testicle, is that a good thing or bad? It's clearly bad. I mean, there's nothing good about it, right? But what did you take away from it, right? Did you learn something from it? Or did you not make that mistake again, right? Did that teach you, something going on in the future? And again, that's something I think engineers are really good at, is thinking about, cause and effect, right? Does everything in this picture make sense? And that's one of the things I really worry about. In medicine, it's so easy to dismiss a data point that's an outlier. You can just dismiss it and say, I don't have to pay attention to that. That's not important. When actually that's the key to a completely different diagnosis that's now life-threatening, right? So, it's a good thing or a bad thing. So what's next? So as part of my residency training when I was at UW-Madison in engineering, I would be told to go in and take a look at a kid's ear. So the number one reason that a kid comes into the emergency department is ear infections. And that's the number one reason for antibiotic prescriptions for kids. And the technology that we use is, essentially it's a magnifying glass with a light source and looking through a speculum. That's what we use to see a tiny tympanic membrane in a ear canal that's full of wax and that's got a twist in it. In all my 3 years of emergency medicine training, I never saw a single eardrum, right? You never saw them. So my attending would say, Jim, go take a look at this patient. I'd come back and say, I didn't see the eardrum, let's start him on antibiotics. Turns out that was never the right answer. The right answer was actually to sear the eardrum. And so this got me thinking that there has to be a better way of being able to see the eardrum with all the technology that we have, right? And I'm sure all you're thinking, well, digital, right? The digital camera. And there were plenty of digital otoscopes on the market. That wasn't the problem. The problem was all the digital otoscopes, like people fall in love with the idea of making the iPhone everything. So they fall in love with the idea of putting a speculum and then making this an otoscope, right? And it's people that have clearly never done an ear exam and don't understand the anatomy of the ear and don't understand the fact that you have to get around wax and don't understand the ergonomics of holding an otoscope and things like that. So embarked on this effort to come up with a better otoscope. And this is where engineering really came in well. Not because I did any of the engineering on this device. We hired engineers down in Washington, D.C. to do this for us. But because I could talk to the engineers, I could talk in their language. I could understand primary, secondary, tertiary effects, right? It could understand trade-offs. I could understand some of the biggest engineering challenges. So for example, our device fits on, you've all been in a clinic room and you've seen the otoscopes on the wall with the black. So our device, you just have to take off the analog head that's on there and put ours on. And now you've got a digital solution. But the problem is that handle that's in that room was meant to power a light bulb, not a computer. And that device that we now market and make has like 6 circuits. It's more like a computer, right? And so the engineering that was involved to make the power systems work, to power that device rather than just a light bulb was really complex. And then to make the ergonomics right and to get the camera, you can't see, but the camera that's in the little girl's ear is 1 millimeter on an edge. And then to get a camera that small mounted properly and to get enough light down to that camera so that it could give you a good enough image. Just a tremendous number of engineering challenges. And I just found that really invigorating. Like being able to talk to the engineers about how we're going to design these, how we're going to solve these problems and then to give them the clinical insight of what it has to be able to do to actually work in the workflow of what a doctor is going to need was really great too. So again, sent in to do an ear exam, couldn't see a tympanic membrane, good thing or a bad thing. Led to the challenge of I want to find a way to solve this particular problem. Good thing or bad thing. Deployed tremendous amounts of capital to engineer this thing and to build it. Good thing or bad thing. Getting good adoptions used at most academic medical centers around the United States now. Good thing or bad thing. Now working on generation 2 of this device that will have Bluetooth and NFC and LEDs instead of glass light pipes and things like that. So again, a good thing or bad thing, who knows? We still haven't told this company, so I can't say it's a good thing yet. So that's what I wanted to talk to you a little bit about today. Is I just wanted to give you some examples of, is it a good thing or a bad thing? And my thesis is, you don't really know. There's elements that clearly are one thing or another, right? Like particularly that young man losing his testicle, that's clearly a bad thing, right? But things happen, and what did you learn from that bad thing happening is half the battle too, right? And did you avoid making that same mistake again in the future? Or did you do even better where not just somebody with testicular torsion, but you expanded that to a completely different, medical problem, and were able to, do pattern recognition to say something just isn't right here, right? So that's what I have. So it was really great to come back and chat with all of you, and I'm so proud of all you being mechanical engineers. It's awesome. Congratulations. Yeah.
All right, we have time for some questions for Jim.
Focus on the ping pong and my major, my championship over.
Yeah. If you could go back, would you have wanted to do med school or like a PhD sooner to kind of get those skills earlier, or was it a good timing, or does it not really matter necessarily?
Yeah, yeah. Thanks for that good question. You know, it's really nice. I'm actually really glad the way I did do it, where I did sort of the business experience first. One of the nice things is, you know, medical school is pretty stressful, right? And because I did it like in my 40s, you know, I was in a different life situation, right? You know, I was pretty sure my wife was going to be home when I came home, right? I didn't have to worry about money and things like that. And so, and I got all those life experiences that I think really made me understand why I was doing medical school and why I wanted to do it. So I think there was a tremendous amount of value with that. I've talked to a number of medical colleagues who did it the other way, who started out as physicians and then have gone on to be sort of entrepreneur physicians. And many of them have said that they kind of wish they'd done it the other way too. So it worked out really well for me. Yeah, thanks.
I was wondering, so you obviously didn't do great in thermodynamics, like you said that. But then what made you interested then to then teach it and to become interested in the ERC and doing a master's degree with such kind of a poor start?
Yeah, exactly right. You know, it was it was not good. You know, I think the thing is, it was never that I wasn't interested in thermodynamics. It was that I was so distracted with something else that I didn't give it the time and attention that it was due. And when I did give it the time and attention, when I went back to retake it, you know, I did just great, as you might imagine. And I found out that I just loved it. I loved everything about thermodynamics, and I loved the discipline of it, and I loved the way, you know, the way, you know, energy balances had to balance, right? You know, and I was that obnoxious kid that if somebody would talk about, you know, like a heat or something like that, I'd explain, well, you know, it's only energy transfer to the boundary, you know. So I really found the discipline and the mental clarity of it invigorating, and then I just loved teaching it. So when I taught Thermo 1, I taught Thermo, I don't know if you still have Thermo 1 and Thermo 2, I taught both of them, I taught heat transfer, but I just loved it. So when I come to class, I'd like bring cutouts of engines and of turbines, and, you know, I'd pass them around, we talk about, you know, we talk about how they worked and stuff like that. And so I think it was just really, the failure was more of an anomaly. It wasn't that I wasn't interested in the topic, it was just that I wasn't focused. Yeah.
It seems like you have a real passion for learning in your life. How are you able to really focus on that while also being financially free and focusing on your career at the same time?
What free?
Sorry, like financially free?
Oh, yeah. You know, it was interesting because, you know, when I went back to medical school, if I don't quite answer your question exactly, let me know. You know, I went back to medical school, and I would never have to work again in my life, right? It just sold the company for a lot of money, right? And it was interesting because I'd go back, and that was never really on my mind, especially not medical school. Medical school I loved because it was just, you know, it was learning, it was studying, it was really good stuff. You know, when I went to Stanford, it was pass-fail, so there wasn't a ton of pressure there or anything like that. What was different is when I came back to do my residency at the University of Wisconsin, residency really beat me up. That was really, really hard on me. You know, what would happen in emergency medicine is you do a 7 a.m. to 3 p.m. shift, and then you'd go home and you'd have to document your patient visits for 2 or 3 hours. And then the next day you do a 9 a.m. to 5 p.m. shift, and the next day you do a 3 p.m. to 11 p.m. shift, and the next day and then in between all those shifts you were documenting for multiple hours, and then your final day would be 11 p.m. to 7 a.m., and your day off would be until your 7 a.m. shift the next day. And I just remember getting so emotionally fatigued with seeing patients. Like it got to the point where like every patient was your enemy, right? Because it was more documentation you had to do. And that really, really got hard emotionally. And it was interesting because I was doing this when I was probably 46, 47 years old. And by that time, you think you know yourself pretty well. You think you know what buttons press, you know, what press your buttons and things. And I found out I didn't really know myself as well as I thought I did. That you know, that kind of pressure and sort of emotional toll really took its toll on you. And the problem was you never got a chance to recharge your empathy. You never got a chance to step back and and be a person again, right? And so that was really difficult. And there were times in there when I asked myself, why on earth are you doing this? But part of it's pride. You know, once you start down something, you know, if you start making excuses, it never ends, right? If you quit once, it never ends, right? And so that was kind of what was going through my mind. But there were some days when, when I thought, I really don't need to be doing this. And the other part too is, like, when you're a resident, you got 3 weeks of vacation a year, right? And so, you know, that was pretty tough too, to have 3 weeks of vacation when you're used to having a lot more free time. And Professor Gandhi and I were talking about before we walked into the classroom, and one of the things I value most right now is the freedom of time, right? To do what you want. You know, we all have responsibilities, but mostly to do what you want to do when you want to do it. Did that more or less answer your question? Okay. You know.
Hey, so it's kind of clear to me that, or it's been evident that you've kind of defined yourself by your pursuit of problems to solve and constantly thinking about different problems that you want to apply yourself to. What has been what has your mindset been? What have been some of the factors that have been able to take you out of that ideation stage into the taking action and actually executing on those ideas?
Yeah. Probably the best example of that is the otoscope I showed you, and I think it was, you know, again, there's one huge advantage that I have over like any other entrepreneur that's just starting, and that's financial resources, right? So one of the nice things to it, after we sold our first company, there was a whole group of us that owned part of Berbee, my first company, and so that group of people that were all part of that all did really nicely on the exit, and then we all went on to, even to this day, we still continue to invest and sell companies. And so one of the real advantages that I have is I didn't have the financial. If I wanted to commercialize that otoscope, I didn't have to go raise money for it, right? I could just write a check myself, and so I could do all the initial development. And what I did is I did all the initial development work myself on my own dime. And then once I was at the point where I thought it had a chance of being commercially successful, that's when I invited sort of all my colleagues, that had been in different businesses together to put money in at the same time. So part of it is, is there a real problem that you want to solve? Is there, do you think there's a reasonable return on the investment? What's the size of the market? So for example, that otoscope, I think almost everybody nodded their head that they've seen the otoscopes in the clinic rooms. There's something like 500,000 to 1 million of those otoscope heads, just in the United States alone. And we don't need a very big market share of that with our device to do incredibly well. And so is there an economic return available for it? Is the problem interesting to solve? And that had kind of all those factors associated with it. Yeah.
So it was kind of hinted at with your introduction, but when you decided you were going to go to med school, were you met often with, like, are you crazy? Or as you said, what on earth are you doing? Or that similar sort of resistance? How'd you deal with that? And, would you say that feeds into that whole idea of, is it a good thing or a bad thing?
Yeah, that's an interesting perspective. I think it depends. I think anybody that knew me, my friends would be like, yeah, it probably makes sense that he's going to go do that. Any like strangers that you talk to would sort of have a reaction of, why on earth would you do that, right? Especially anybody that was in the medical field that had gone through it. That's always one of the questions that comes up too. People always ask me, would you do it again? And my answer is, there is no way I would do it again. But am I glad I did it? That's two completely different. Am I glad I did it? Yeah. But knowing that I know now, would I go through it again? There's not a chance I'd go through it again, right? And it was probably, as you might imagine, the big issue was my wife, right? And I still remember I was actually down in Texas, as at some flight training down in Texas when I got Stanford was actually, there was such a small class, they actually called everybody and said, hey, congratulations, you got into medical school here. I remember I was like, really, I got into Stanford? That was like, so I called my wife and I said, hey, we got into Stanford, how do you feel about going to Palo Alto? And that was a little tougher sell, so I had to agree to get a couple dogs, so a couple dogs came out. That was a good thing, it was a good thing and a bad thing. I don't know, it comes back to my point too, at least, I think you always have to be engaged in something. Being idle is no good. You got to have something that you're working on and something that you're interested and passionate about. And it can be almost anything, but just the days are pretty long if you're just sitting around, right? So, and the nice thing too is even though I don't practice clinically anymore, I maintain my license. And so one of the nice things, if I have colleagues or friends that need an antibiotic prescription or something like that, or as you might imagine, I get a lot of questions about my ear doesn't seem to be working. So it's nice to be able to help people with those kinds of things. I carry in my car, in the back of my car, I carry a defibrillator, because I always ask myself, one of the questions I always used to ask residents when I was training medical students or residents, I'd always ask them, okay, if you're going out to the wilderness, tell me some of the things that you want to carry with you out in your wilderness. And there's only a few things that are really life-saving, right? Antibiotics, yeah, they make you feel better. Probably not life-saving unless it's a lot of time, but things like epinephrine is life-saving, right, for anaphylaxis. Things like a defibrillator is life-saving. Things like albuterol for an asthma attack is life-saving, right? So it's kind of nice to be able to have those skills.
When you were studying mechanical engineering, did you always think you were going to start a business? Did you think you were going to work for IBM for the rest of your life? Or what was your thought process on what you wanted to do at a young age?
No, it's funny because my dad was a professor at the university. My dad was a professor of forestry. And he was never a particularly happy man. And, he's always kind of talked about how he wished he'd had a business and stuff. And so I was the kid that was always mowing lawns, right? I was shoveling snow. I was delivering papers. So I always knew I was going to do that. In fact, the reason I was smiling when you asked me the question is when I was interviewing at IBM. This was back in the days. IBM used to have this reputation of lifetime employment. Once you were hired at IBM, you were hired for life. That concept is foreign to everybody. That doesn't make sense to anybody anymore, right? But that was back when I started in 1989, that same year that I beat Jal at ping pong. That was the mindset. And I remember I was with the branch manager at IBM, and he was saying, "Well, Jim, here's the thing. We're making this hiring decision about whether or not to bring you on board, and I'm making a lifetime decision." And this sounds really arrogant, but in the back of my mind, it's like, "Oh no, you're not, buddy." Not that you weren't going to pay your dues. Everybody has to pay your dues, right? Everybody, you work hard and all that kind of stuff. But you just clearly knew that no, that wasn't going to be my path. And to this day, I could never imagine working. IBM was a great company to work for, but I've never worked again for anybody since that time, and I can't imagine ever doing it again. It's even when I was a physician, you nominally worked for somebody, the health system, but you didn't really have a boss, right? You kind of did your own thing. But I tell you, being an entrepreneur and living and dying by your own decisions is really, really nice. Thank you for the question.
Other questions?
All right. So you were kind of talking about retrospectively. Was it a good thing? Was it a bad thing? How are any thoughts on forward thinking when you're making a decision that has a lot of uncertainty? Any heuristics there, and any thoughts on that?
Boy, that's a tough question to answer. I'm trying to think if I could give an example of something that's happened recently that would help illustrate that. I think one of the things when I was sitting in this room, the room wasn't this nice when I was sitting in this, but when I was sitting in this room, for me as an engineer, everything was black and white. There was right and wrong. There was black and white. There was good and evil. I think one of the things I really have taken away is there's a lot of shades of gray and everything, right? And I think trying to understand those shades of gray and sort of predict what the outcomes of a particular decision will be. I think it's very fair to say that I think things through a lot more carefully and a lot more deeply than you used to, right? In terms of the possible outcomes. I don't know that I have any specific heuristics. It's kind of lifetime learning, lifetime muscle brain memory. I've seen this decision be bad before, right? Turn out badly.
Well, you kind of said the possible outcomes, so that's kind of one. You do. It sounds like you do kind of think through all,
Yeah,
and that's definitely an engineer's way.
It
of
is.
failure modes,
It is.
thinking what could go wrong. So
No, that's exactly right.
that's
Yeah,
pretty cool.
that's
All right,
exactly
thank you.
Okay, any other questions? If not, I get the chance to present you a gift, Jim,
Sweet.
for some takeaways from your home department of mechanical
awesome.
engineering.
Oh, awesome.
Lots of tidbits and
Oh, great. I got
glasses
pins. Oh,
and-
perfect. Thank you.
and even socks
Look
if
at
you
that.
still run. So,
Thank you. Appreciate it very much.
anyways, on behalf of mechanical engineering, thanks so much, Jim, for coming back and sharing your story. You set the bar high for all these students out here are thinking about what they're going to do next.
I'm just glad I got here before the astronaut. I saw you have an astronaut. He wants to follow the astronaut.
There's still time, man. I assume you're not done yet. So, anyways, thank you. It's really a pleasure to have you back with us, and I really appreciate it. Thank you.